Hello guys, last time we were exploring through surveys and experiments and we ended up not ending the experiment part, and today we're going to be doing the rest of it. So we said that in an experiment, first you gather samples and then you divide the groups. Next you use the treatment. Lastly you evaluate and compare the results, and that's the procedure of the experiment. So in dividing the group part, what happens is that there is a control group and there's a treatment group. So you divide the samples into two different groups. The first group, as you can see here, is the control group where there's no treatment applied, and the second group is where treatment is applied. So why do we do this? Why do we divide the groups into the group with treatment and group without treatment? The answer is to make it easier to see the effect of the treatment, and in other words, to make it for a better comparison of how effective the treatment is. So, for example, let's say we have a seed here, and in this seed, let's say one group of seeds, we're going to be applying this chemical, and the other group, we're going to be doing nothing. We're just going to let it grow naturally. If we do this, then it'll be easier for us to see how effective this chemical was to the seed. Did it make it grow better? Did it make it worse? Is it more fruitful or is it less fruitful? Is it fruitless? And comparing with the one that grew naturally. So how different would the chemical do compared to doing nothing on the seed? This is why we divide the samples into two different groups, the control group and the treatment group. Now, third step, using the treatment. This is where the experiment actually begins. And when using the treatment, there's just one thing you gotta know. In the treatments, when you perform the experiment, there's gonna be several variables. First is gonna be factors. Second is gonna be response variables, and third is gonna be control variables. So, what's the difference between these variables? Factors is what you apply. It's the treatment, and the response variable is the result from the treatment. So going back to the seeds and the chemicals is the factor, and if we assume that the seed grew like 5 more centimeters taller, then that's the response. So response variable. So the height of the seed will be the response variable because that's the difference we're concentrating at in this example. So that's what the responsive and the factors are. Now you may have noticed that I put the factors and responsive variables next to each other and an arrows between them to show you kind of like a uh, cause and result effect. But you've noticed also that there's a control variable underneath. Why did I put the control variable underneath? Before that, what is a control variable? Control variable is something that's going to be existing and you can't really do anything about it. It's a variable that's applied to all the samples. So what do I mean by that? For example, in this experiment, the seeds and the chemicals, all the seeds here, what will be the control variable for this? The one you can't really control. If it will be the amount of sunlight they receive, you can't really control the amount of like solar energy each plant receives. You can't really do that. You're just gonna leave them outside getting the sunlight, and you can't do anything about it. Also, when you let them grow, it's likely that it's possible that some insects come near the plant and they eat some parts of the plant, which could potentially impact the response variable, and that would bring us an incorrect, inaccurate data result, which is bad for the experiment. And also the quality of soil. Well, this one you can actually control it by giving them the same soil from the same place, but still you can't really guarantee all the soils are exactly the same. And there are several others. All these are control variables which has the potential to result in an outsider in your database, in your data from the experiment. This is the control variable. So now we're going to wrap up with these last two features of an experiment called placebo effect and blinding. So these two, an experiment can be successfully performed without these two, but these two have the potential to occur in an experiment. So what is a placebo effect? Placebo effect is when a patient has not received a treatment but believes that he or she has received it, and their status of health has actually gotten better just through their belief. They didn't receive anything, they just believed they did, and that belief has made them become healthier and in a better condition. So it usually happens when developing new medicines, because the scientists use that to check the effectiveness of their medicine. But this is not a scientifically proven phenomena, so it is not used in official treatments because there is a high risk of it not having any effect on the patient. And so what's blinding? Blinding is literally when the 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 sample, the people who take the treatments, do not know whether they have received the actual treatment or whether they have received the false treatment. So they don't know if they're the control group or if they are the treatment group. In some cases, there are cases where even the experimenter themselves don't even know who received what. They just observe and get the result. So why would you want? In which cases? Oh, so placebo effect, something. It's an effect. It's a phenomenon that could occur. You can't really do anything about it. But blinding is something you can do. You can change in your experiment. So in which cases? Why would you want to do blinding in your experiment? Well, there are two reasons basically. First is to avoid selection bias. So if you don't know who's receiving one, you really can't do anything about the selection bias. It's not going to be biased at all. Everyone's going to be having a fair chance of receiving a treatment or not the treatment. And second of all, to this is to prevent the placebo effect, so that the ones who are taking the treatments, so if they don't know if they're taking the treatment or if they haven't taken the treatment, then placebo effect can't really work because they don't know if they received the real one or the false one. So by preventing the placebo effect, you can see the better results, and you can of the pure effectiveness of the pill. So that's it for today. Thank you for watching, and this is gonna be the last chapter from statistics. Thank you for watching until now.